Tardigrades by Facepon. Water. It is required for all life here on Earth and is essential for human existence. It comprises the majority of the human body and is used by all cells, tissues, as well as organs in our bodies to maintain their bodily functions. A couple hours without water and we begin to feel thirsty. Our mouths begin to dry and our lips become chapped as there's less saliva being produced. Our urine becomes darker and less is excreted from our bodies in an attempt to conserve more water. As we become even more dehydrated, we begin to feel fatigue and our blood pressure drops. Eventually, our brains, which is made almost entirely of water, even begins to physically shrink, pulling away from the skull. Without water, we will only perish shortly after a few days and shrivel to an excruciating death. However, there is one creature that's able to survive without any water for an extremely long period of time, the tardigrades. Tardigrades are extremely tough. They're able to go for decades without any water and yet still exist. Similarly resembling the hookah-smoking caterpillar from Alice in Wonderland, tardigrades are able to withstand the harshest and most extreme environments on Earth. From temperatures near absolute zero to even scorching dry temperatures of 300 degrees Fahrenheit, these microscopic animals persist. They can even survive exceedingly high radiation levels, high atmospheric pressures, and even the darkest depths of outer space. These creatures may seem small and chubby, but they are the toughest animals on Earth. They are found living on nearly all habitats, from the deepest depths of the ocean to our very own backyards. To survive extremely harsh environments, tardigrades have developed a special adaptation called cryptobiosis. During cryptobiosis, tardigrades curl up like a dehydrated ball and enter a lifeless, dormant state called the tun state. In this state, their metabolic activity slows down or even stops completely, resembling death. They lay in this state like Sleeping Beauty for months, years, or even decades, waiting for an optimal and safe environment to wake up in. Once the environment returns to an optimal state, tardigrades break free of their tun state, pop their heads and legs out, and resume normal functioning life. It has remained a mystery as to how tardigrades are able to survive the driest regions of Earth and become the very first animals to survive in outer space. It was thought at first that the tardigrades used a sugar called trehalose to survive desiccation. This sugar has been found in other desiccant-tolerant organisms like yeast and bacteria. Yeast and bacteria produce trehalose as a protectant for their cells. When dried, the sugar becomes almost glass-like, preventing their cells from drying out. For decades, scientists have hypothesized that trehalose may be the key that allows tardigrades to have such extraordinary powers to survive extremely dry environments. However, a group of scientists led by Thomas Boothby sequenced a variety of tardigrades genes and discovered that the trehalose sugar was not produced. This ruled trehalose out as a potential molecular mediator. So this group of scientists further examined the tardigrades genes. They saw a remarkably high activity expressed from a set of molecules during desiccation called intrinsically disordered proteins. These proteins lack the three-dimensional structure of a regular protein. To test whether these tardigrade proteins are actually responsible for tardigrades to survive desiccation, they used a method called RNA interference. This method basically shuts down and silences the genes that encode for the tardigrade proteins. What they discovered was that the tardigrades basically died. This confirms the definite role the tardigrade proteins played in allowing tardigrades to survive extremely harsh environments. Through convergent evolution, these tardigrade cells have gained the ability to enter a glass-like state when dried, just like the sugar trehalose. However, instead of using a sugar to do so, they use a protein. You may be thinking, how are these little chubby creatures so important when they seem so small and useless? Well, tardigrades may be more important than you may think. Determining the genes responsible for allowing tardigrades to survive desiccation and understanding the mechanisms behind it will provide a foundation for researchers to apply these mechanisms to a variety of applications. The genes that encode for the tardigrade proteins may be put into smaller organisms like yeast and bacteria, allowing them to express the tardigrade proteins. This will boost their ability to survive desiccation and prolong their lives even further. Tardigrade proteins may even boost the resilience of larger organisms such as humans and improve our quality of life. By genetically engineering human cells to express the tardigrade proteins, we can boost our ability to survive in extremely dry environments. We can become just like the tardigrades. We can even apply this to genetically engineer crops to become resistant to droughts. This could end famine in other countries around the world. We can even stabilize pharmaceuticals such as vaccines. Vaccines are highly unstable and are easily damaged. They need to be stored in cold temperatures and require refrigeration when shipped. Now that Boothby and his team have found the proteins responsible for the tardigrade's indestructible ability to survive desiccation, they are one step closer to applying tardigrade's tolerance to stabilize vaccines in a dry state and ship them throughout the world. Not only will this be cost efficient, but it will save many lives, especially in remote areas lacking refrigeration. Tardigrades may be small and chubby, but they will benefit all of us in the future.